So in this fourth video of this lab, we're going to look at the proposed modifications to the driver's license office. So recall in the previous videos we implemented the current configuration where applicants arrive, go through check-in, written exam, and check-out. And we created the corresponding Simio model and went through a verification exercise to make sure that we had modeled the system correctly. So for our modification, what the Driver's License Bureau is considering is adding an optional computerized exam kiosk. And so they're going to replace one of the two exam clerks with this computerized kiosk. And the computer kiosk supports two exam takers at a time. And we're going to initially assume that one half of the applicants choose the kiosk and that the exam time is the same as with the human clerk. So now when a applicant leaves check-in, half of them will choose the human clerk and half will choose the computerized exam kiosk. So let's start with our previous model and make the modifications. So the first thing I'm going to do is I'm going to rename my exam to be human exam and go change the capacity from 2 to 1. Because as we said, we're replacing one of the human exam clerks with the computer kiosk. So what I'm going to do is I'm going to now create another instance of the server object, and I'll name this computer exam and fill in the properties. So we have capacity 2, and we want the same processing time characteristics as with the human. So I'm going to just copy that and paste into the processing time properties. And so we have this exponentially distributed 8.8 unit in minutes. And so the remaining thing that I have to do is to connect the computer exam to the check-in. So I'm going to use multiplace again. So I double click on the path object in the standard library, and then I'm going to connect from the check-in to the input of the computer exam, the output of the computer exam to the input of check-in. Since I still see the crosshairs, I'm still in multiplace mode, so I'll hit escape to get out of that. So now what we see is we have two paths emanating from the output of check-in. And so if we just run the model without doing anything else and let it run for a little while, and we can see that we have some entities that are going to the human exam, other entities that are going to the computer exam. And as we watch, we can see that the maximum number of entities processed in the human here in the process station is 1, and the maximum number at the computer exam is 2. So we have in fact implemented this logic where we've replaced one of the human exam clerks with a computer kiosk that supports 2. The only remaining thing is to consider how the entities make this choice. And by default, if we give Simio no other information, Simio makes the selection randomly using the selection weight properties of the paths. So I have two paths, path 2 and path 5, and they both have the default selection weight of 1. And so what Simio will do is determine the proportion by taking the individual selection weight of 1 divided by the sum of all the selection weights. So I'm going to have half the entities go this way and half the entities go this way, and the selection is made completely randomly. So now that we have the model initially done, we ask ourselves the same question we always ask ourselves when we complete a model task. Have we modeled this correctly? In other words, we need to go through the verification process to make sure that we've implemented what we think we have. So what we're going to do initially is run in fast forward mode. So I'll leave it at 1,000 hours for now, and we'll run in fast forward mode and then look at the pivot grid. But before we do that, it would make sense for us to try to think about, what do we expect to happen? So what do I expect to be different since I've made this modification? Well, if we think about it, the human shouldn't change much at all because we've reduced its capacity from 2 to 1, but we haven't affected the processing time, but we've reduced the arrival rate by 1/2. So we would expect the human to be about the same in terms of utilization as it was before. The computer exam we would expect to be roughly half, because we have cut the arrival rate in half relative to the human exam, but we still have 2 units of capacity. So what we'd expect to see is a utilization approximately 1/2 of what we see for the human. So we can go to our results, and we see that we have about 12.2, 72 minutes in the system. Our check-in looks about the same. Our checkout looks about the same. Our human exam, again, looks roughly the same. And as we expected, our computer exam looks to be roughly 1/2. Of course, this is only one single replication, so we would also want to go back and look at our experiment that we did previously. So I'm going to reset the experiment, and this time I'm going to reduce this down to 500 hours. And let's do a 100-hour warm-up just so we can save a little bit of time, and run my 25 replications. And again, as the replications run, we can watch the pivot grid, and you can watch the values change. And so now, in addition to the average values that we saw from our single replication, we have the confidence interval half-width values that give us information about the sampling error. So go back to the design, complete our 25 replications, and then go back to the pivot grid, and we can see the actual changes in values are roughly in line with what our expectation was. Since we've now talked about the multiple paths emanating from a server, let's go back to when we discussed having applicants fail the exam. So what we talked about earlier in the previous video was adding an additional sync for entities that failed the exam. So this time what I'm going to do is I'm going to connect my computer exam and my human exam both to sync 2. So I've got the second sync. So we will then go rename these. These are paths, and let's rename these fail. And so now we have 2 paths emanating from both sets of exams, the computer exam and the human exam, going to this failed sync. And now what we should see when we run is 3 different times in system. We should see a time in system for all applicants, which will be with respect to the applicant object. We'll see a time in system for those applicants that pass the exam, which will be with respect to the pass sync object, and the same thing with the fail sync object for the applicants that failed the exam. So if we run our model, let's run it in fast forward mode. We'll just do one run in interactive mode and then go look at the results. And now we see with our sync we have 2 different time and system values, and we still have our time and system value for our model entity. And so as we expected, we have 1 value for the entire population of applicants, we have 1 value for those that failed, and we have 1 value for those that passed. Also, as we should have expected, the failure time average is smaller than the pass time average because those that fail the exam don't go through the checkout process. So we would expect this to be approximately 9 minutes shorter, plus whatever waiting time there was in the queue for the checkout station. Looking back at the model, we created the failure sync, and then we just connected from the output of the computer exam and the human exam to this failure sync, and we didn't update any of the selection weights. So recall that Simio, if you don't tell it anything differently, it routes randomly using these selection weights. So we can easily change the failure percentage by simply manipulating the corresponding selection weights. So for example, if we want to say that 10% of the exam takers fail, we can set the selection weight for the failure path to say 10, and the selection weight for the pass to say 90. And so now we have a 10 selection weight and a 90 selection weight, and since Simio will take the individual selection weight divided by the sum, we'll get 10 divided by 100, or 10% on this path, and 90 divided by 100, or 90% on the checkout pass. So we can do the same thing for the computerized exam. If these two percentages are the same, we can make 90 10 and 90. And now when we run our model, we would see far fewer entities fail. So let me stop and run. And then we can go back and look at our results, and we see that the results have changed just a little bit. And we can also look at statistics and look at the observations. Let's see, is it observations? Yeah. And now we can see, we can compare the number of observations of entities that flow through the failure as 487 and as through the pass at 4,393. So again, we're roughly seeing 90% go this way and 10% go this way, which is exactly what we were trying to achieve. So before we do the in-class assignment, I'm going to undo this, since we're not really interested in failures. I can just simply leave the name pass, and at this point, since we don't have multiple arcs emanating from the exams, it doesn't matter what the selection weights are, but I'm going to put them back to their original values, just so that I'll know that I didn't make any modifications